Hello everyone, my name is Alessandro De Maria. I'm one of the founders of Kapitan, Kapitan.dev. This is one of my first videos where I will try to explain some of the components of Kapitan. We've been asked many times to explain some of the functionality. I think showing it by video is the best way to explain the full potential of Kapitan. So let's get started. So first of all, we have a website, Kapitan.dev, from where you can get loads of information about Kapitan, documentation. And for this kind of initial video, which we will dedicate it to one of the components called the inventory, which we see here in the Kapitan overview. We can find all the specific documentation and also especially important the getting started section, where you can see how to quickly clone our reference repository, which we will be using for the rest of this video. As I said, documentation is here on the website. Let's get started. So here is a Visual Studio Code, which I have already configured using something called Gitpod. So we have a remote Gitpod server running, on which I have downloaded and cloned the Kapitan reference repository. Going to explore all the different kind of initial components of Kapitan. For the time being, I can show you that within the Kapitan reference folder, one of the first commands that I usually run is the Kapitan compile. We will get into details. I'm going to assume for this video that you have some sort of an idea of what Kapitan is, but nothing more. So I would imagine you want to understand a little bit more how everything works. So if you are an experienced Kapitan user, this is probably not going to give you much value. But if you want to get started with Kapitan and learn the basic aspects, I think this is going to be the initial video that you could follow. So running Kapitan compile runs a series of action of compilation that we see here for a number of what we call targets. So each of these kind of line represents a different target that is being compiled. And this is a series of examples that we have on the default Kapitan reference repository. In another video, I will probably show how to start from an even more bare setup. But for the time being, we're going to use this Kapitan reference, which is the quickest way to get started with something and to see some sort of examples. So on the left-hand side in the directory structure, you can see that there is a directory called inventory, which is going to be what we're going to discover today. And there are two main subdirectories, classes and targets. These are the only two kind of mandatory kind of classes, folders that we have within the inventory. Everything else is basically going to be a series of subdirectories and files that are completely up to you to configure and to map to whatever kind of configuration better suits your specific environment, specific situation. In the targets subdirectory, in this case we see like a another structure of other kind of subdirectories. So for instance, we see the examples one, Capicorp and Terraform. Again, this is kind of completely arbitrary and up to you. For the time being, for this kind of video, we are going to basically create a new target, and we're gonna see perhaps look into a couple of these to see some examples. So a target, first of all, is what tells Kapitan what we want to basically deal with or compile or set up or take into ask Kapitan to take into consideration. So for instance, the MySQL target here will basically represent some sort of will give some sort of indication to Kapitan of what we want to compile by using classes that will basically import different kind of types of configuration, and ultimately also what we want to add as extra parameters to what has already been implemented and imported by from some classes. So in this very basic example for MySQL, we see that there is a concept of a common class, which is something, again, none of these kind of configurations are mandatory in a way. You can configure whichever way you want, but in the kind of configuration we have at the moment, common represents some sort of boilerplate that we recommend or expect Kapitan to have in order to work properly. And then there's going to be another class, which is components.mysql, which, as the name seems to kind of hint, contains information on how we want to configure the generate the configuration for the MySQL component. There is also a section called parameters, and that we can see only one specific kind of parameter being defined, which is target name, being MySQL. We're gonna get into that very quickly, but for the time being, let's look at classes first. So if you recall, we have a subdirectory called classes here under inventory, and you can already start to notice that there is a file called common.yaml, which is straight under the classes subdirectory. So in this case, we can assume, or we can actually start to kind of reveal the fact that the classes that we see listed here map to files in the classes subdirectory under the inventory Kapitan directory. So we can see that common.yaml contains some basic other information, one of which is loading yet another class and setting some other parameters here. So we can try to follow the trail here. We see that common loads kapitan.common, and we can again see that there is a subdirectory here called Kapitan that contains a common file. As you can see, there are more and more classes being kind of added, and each class will allow you to define or to configure Kapitan in a specific way. For the time being, we are not going to look into the common class too much, but we are going to assume that common imports some valuable and important types of information into that allows Kapitan to work. So let's go back to our target, which is the MySQL one. And now let's look at the components.mysql here. So components.mysql in this case again maps to classes, components, and then there will be a MySQL file here defined. And you can see that again there are like a series of parameters. The classes kind of definition is disappeared, which means that this class is not loading it's not kind of importing any other kind of classes, but we have straight a set of parameters here that we see defined. Now, nothing about Kapitan is, well, there are few of the configuration about Kapitan are dictated by our setup. Most of the time, we allow for people to express their configuration whichever way they want. However, some of these kind of parameters do assume special meaning, and we're going to look into that soon. For the time being, let's focus on the inventory itself. So let's not focus on what Kapitan does with the inventory. Let's just focus on the specific things that you can do within the inventory to organize your data and your structure. So for the time being, just assume that this is just what you're trying to do at the moment is just import and create import fragments of YAML and finally create the inventory, which is the final rendered structure that contains all the YAML fragments that you've imported. So if we go back to the MySQL target here, I'm gonna put like one side by side. We can now say finally, after having opened these two files, so common and components.mysql, that when you define classes into a target or in any other file that is being loaded by inventory, what we mean is to import the specific fragments of YAML that are defined into that file, and basically one by one add and merge the fragments coming from subsequent classes into one. Ultimately, in the target file, the final setup, the final value can be further overwritten by using the final kind of parameters section, where we are able to override anything that might have been imported from previous classes. So in this example, we see that we're using target name equal MySQL. Now, let me run a command that will allow to show the current state of the inventory for the target MySQL. So we can start basically looking at what happens and how Kapitan can be used to, and the inventory can be used to influence the structure that we have for our setup. So I'm going to go back to run the Kapitan command. This time, instead of the compile command that we used before, which we're going to get into detail quite soon, we're going to look into the another command called inventory. And to make sure that we look at just at the imagery that's being generated for the MySQL target, which is the one we're looking at, I'm going to add the -t command line option with MySQL. When I do run this command, what happens is Kapitan will read the MySQL.yaml target, read all the classes and all the nested classes within those files, take all the different YAML that is present in all these classes, merge it together, and present finally as a final rendered object, which we call the inventory. If you look at it, you can see that there are a couple of different kind of keys. There is a reclass key. This is time to explain that Kapitan uses for the inventory, uses a library called reclass, which is something that you will find in our repository. Then you will see other keys called applications, classes, parameters, environment, exports. And some of these classes are used within Kapitan. Like for instance, some of these keys are being used, while some other are ignored, and they are just there to because of the original use of reclass, which we are not taking advantage of in a way. So we are not using the applications key. So this is something that at the moment I cannot find a use for it for within Kapitan. We're using the classes, and we can see here that we can already find the two classes that we can recognize from this file, common and components.yaml, while all these other classes were somehow imported by a chain of other files importing them at one point. So we can now see all the classes that were somehow imported directly or indirectly by this MySQL target. The other um, the other key that we use much more is the parameters key. And the parameters key, we can basically see that it's gone from just having one component here, target name, to actually becoming the biggest kind of parameter within the inventory. And this represents basically all the different fragments of YAML that were imported by the different classes that we see here in this list. And we are basically getting one final representation of all those kind of fragments into what effectively becomes the inventory. First thing I want you to notice is kind of a special key called reclass here. We're going to go into the detail for that in a second as well, and explain how we take advantage of this. This is like a specific key that is made available by reclass, and we take advantages like metadata about the target itself. We can immediately notice that there is like this reference to MySQL, and I can tell you that this is basically coming being injected based on the name of the target itself, but we're going to look into that in a second. And then we can see there is like a key called components with, in this case, MySQL, which is what we saw here in the MySQL subclass of the components directory. As we can see, there are lots of information that we've dragged in from importing all these different kind of subclasses. We're trying to now look into some of the specific behavior of the inventory, and then we're probably going to explain some of what the meaning of some of these kind of configurations that we have. For the time being, as I said, I want to kind of focus on the basics of the inventory. And in fact, I think the best way to go about it is to create a new target so that we are not distracted by the fact that we are loading the MySQL class, or we're not trying to understand what MySQL is trying to do at this time, but we're going to start fresh with a brand new target file, and we are going to use that as an opportunity to investigate and to see all the different features that are available, the Kapitan makes available through the inventory. So let me close these two files now, and what I'm going to do is just to show that it doesn't matter really the directory where we are in, we are going to create a new file which we're going to call Loom, because I know for sure that nothing exists with that name. We're going to call it loom.yaml. And at this point in time, should I try to compile the loom file, so the loom target, most likely we are going to see that there is a very basic kind of inventory being created. This is the most basic kind of inventory that we can have, and I use here the wrong command because I didn't want to show the inventory, I wanted to compile. So we're going to see that if we actually try to compile it like we did before with everything else, we are going to see that Kapitan is unable to find that target definition, and this is because, as I said before, we kind of need some sort of a boilerplate which will be provided by using the common class. So let me try again here to do a Kapitan compile for loom, and with a bit of luck we should see that now Kapitan is able to compile loom as a target, whatever that means, because at the moment we don't have defined anything. We haven't defined anything. So if something is being compiled, is somehow because something in the common classes tells Kapitan what needs to happen for a basic bare target that we created. Time to show you something else. You can see here there's another directory called compiled, and if you look in the compiled folder, You can now see that there are like lots of directories, and you can also identify a new directory called loom, which is the one that we just created right now. You can see it's green because it's being added. And when you look into this kind of directory, at the moment you can see a number of subdirectories being created automatically. For now, let's just ignore what's happening, but I just wanted to show you that there are some files that are being kind of created by default, like for instance the loom namespace and the readme.md. For the time being, just wanted to show you that when you do compile a file, there is something that pops up in the compiled subfolder. But as I said, for this specific tutorial, I just want to focus on the setup of the inventory itself and the capability of the inventory. We are going to see how to compile, how to template, how to do other things in other tutorials that we will have later on. Now let's go back to, let's look again at the inventory for Loom, and we can see that at the moment, actually let me run it again. So we do the Kapitan inventory for Loom. We can see that now that we've added the common class, the inventory has become already much bigger. And one of the things that I want you to notice is that there is like this kind of target name already defined as Loom. Now, if you remember, in the MySQL target, which was under examples here, in the MySQL target, we actually had it defined explicitly here. So how come that now for this specific file, for Loom, the target name is already populated with the correct name? The reason for this is that one of the magic that happens in the common class, which in the MySQL case, we are just basically explicitly resetting just to prevent people from not understanding what's going on in a way. But one of the things that happen in the common, if we open the common class, you can see that there is already a parameter where target name is being associated to this kind of a special string that we see here, which is this $, and a series of kind of instructions. Now, if we go back into the inventory, we can recall that we saw this reclass earlier on, and reclass is right here. So under parameters, reclass, and then we can identify name, and then we can identify short, and this maps, in the case of Loom, maps to Loom. So what is happening is that we finally encounter one of the first and most kind of powerful functionality that we have for the inventory, which is the ability to set a specific parameter with the value of another parameter that is already predefined within the inventory. So we said before that this reclass is kind of automatically populated, so it's just magic that we find within our setup. But in this case, we are actually taking that magic and setting it to a new parameter that we defined, which is target name. And you can see that the same thing is happening for namespace as well. We are somehow setting by default the namespace parameter to be the same as a target name. So first of all, we are going to deduce from this that it doesn't matter whether a parameter is being set up before or after when it gets used, as long as they are both kind of existing. So we didn't have, for instance, to set up namespace only after we already set up target name. So the inventory is clever enough to not to care about the order on which this kind of assignment happened. And we can also start to kind of deduce that the syntax to connect to address and to select a specific YAML value is using the $, the open brackets, and then the path to the specific file that we want, to the specific value that we want to override, with using this column as a way to separate all the to define the path that gets us to that value. So let's try to see how we can start playing with this and make it somehow show some other kind of characteristic of the inventory. So remember that we are just editing the loom.yaml file at this moment, which contains at the moment just classes and common. And just to recap, if I do Kapitan inventory loom, this is the file that we have at the moment. So we have the target name mapping to loom. Now, as I said before, we can use this parameter section to further redefine and reset eventual things that have been imported and set up earlier on in the classes that we've imported. This allows us to define generic default values in the classes, and for each target somehow provide an override that allows us to customize to the specific needs of our target. So let's try with this, and let's say that we want to change the namespace value, which until now is set up to loom. We want to change namespace, and we want to call it Kapitan. Okay. So what is going to happen now is that while here, because of the instructions in the common.yaml file that we saw before, namespace was being defaulted to the same name of the target name, so loom. If I now run Kapitan inventory again, I will see that the namespace has changed and has respected the fact that in the target file, I ultimately decided to override a specific name to be, in this case, Kapitan. This is kind of a first example of how we can override parameters. When we override parameters, we can still take advantage of this variable interpolation that we did before. So what we can do it just to make it a little bit fancy. I'm not saying that it has any specific helpfulness at the moment, but we could still use the syntax we saw before to append target name to the name of the namespace, in case we wanted to kind of come up with something a little bit more complex, where we have Kapitan as a prefix and then the target name as the suffix of the namespace. So again, if I do Kapitan inventory -t loom, we can see that now the namespace has changed and is going to be kind of a using this kind of a hybrid setup. It has a fixed string as a prefix, and then it's interpolating the value of target name as a suffix for this specific string. Now it's important to notice that at this point, namespace doesn't mean anything to Kapitan. It's just a simple variable. So we at the moment, although we saw that there is a file being created here, but technically for the mechanics of the inventory, namespace is just any variable. It could be something completely different. In fact, we can actually, if we call it space, from when we run Kapitan inventory, we can see that now there is a space parameter that becomes Kapitan loom, and then there is like the namespace reverts to the default that we had defined previously, which again maps to loom. So what we learned until now is that we have a way to define parameters, and we have a way to refer to values that were preset by other classes or by other through other mechanics, and we can refer to them through this kind of variable interpolation that we have for the inventory. We are approaching 30 minutes, so let's see what else we can do now to just show some examples, and then I think we can stop it here regarding the inventory and perhaps move on to another topic with the next video. But for the time being, let's just show another kind of aspect, another functionality. I'm going to make a step ahead. I'm going to say that there is a special functionality that we have within Kapitan, which is which allows us to create easily create Kubernetes manifests. So we are going to use now to create a very basic setup, and then I'm going to show you how some of the kind of ways of importing data into specified data, still using the inventory and using the power of classes. So let's assume for the time being that we are going to create another component, and let's assume that there is a component that we might call even just MySQL for the time being. Actually, wait, let's call it like Nginx. And we are going to say that there is an image for Nginx, which is Nginx again. Now, why this happens is something we're going to look into another video. But for the time being, what you need to understand is there is some sort of magic, something called generators, that when we find that there is like a sub key to something called components, we assume that we want to generate configuration file for the for that kind of sub key. So for a deployment of with that name, with the Nginx name, and we also assume that pretty much the only bit of information we need to generate a deployment is the key that represents the image that we want to generate. So let's run Kapitan compile -t loom, and let's materialize basically this configuration. Let's see what happens. So we compiled loom, and if I go back now in the compiled folder for the loom subdirectory, in the manifest subdirectory, we can see that there is now a file called Nginx bundle. When I look at the Nginx bundle, I can see that there is something that looks like a standard deployment with some defaults that have been kind of defined. The only thing that I actually recognize is the fact that there was an image called Nginx, and another giveaway is the fact that the name is basically the same name that we define here as a subkey. Doesn't matter to create actually something that it's whether it's an actual Kubernetes working setup. I just want to show you some other aspects of how to organize your inventory for the time being. So let's assume that that file is something that we intended to generate for some reason. This point in time, we have defined, first of all, we can get rid of space here because we don't need it anymore, but we define this component straight into the target. When you define things in the target, basically you don't have the ability to then share that specific information with the other targets where we might want to also generate a component called Nginx. So one of the earliest things that we learned to do is to basically take this kind of YAML fragment and move it to a different location so that it allows us to organize our files better, our inventory in a better way. So before I go and I do that, I'm going to run Kapitan compile once more, and I'm going to, for the sake of this kind of example, I'm going to add all the files that we have generated until now, and I'm going to commit to something like initial Nginx setup, and this will come handy in a second, so we can see some important characteristic about Kapitan. So we added a new commit. we have this kind of basic target setup. Now what we're trying to do is organize our data better so that we can organize our inventory better and show some of the capabilities that we have. So let's do like this now. We are going to create a new class, which I'm going to create under the classes component subdirectory, but this is entirely up to me. I could also, actually, let's create a new folder called Kubernetes, just to deviate from this setup, and then we're going to create a class called nginx.yaml. At the moment, this is an empty class, but the intention is to use this class to contain this information that we have here for the generation of the component nginx. We said we don't care whether the actual component is a valid component, we just want to show the benefits that we have in relocating this kind of YAML segment somewhere else. So what we're going to do is just literally cut everything that we have within this kind of setup. Because we don't have anything defined into the parameters, we can actually remove even the parameters key. We are not using it anymore. We are going to move it into the nginx file. Now, if I were to compile things now, because in the Loom target, we haven't yet told how to load the newly created kubernetes.nginx class, what's going to happen now if I compile Loom again is that at this point Kapitan doesn't find the previously defined components called nginx, and if I look at the git status, I can see that all the files that were before that had been created for that component called nginx have now been deleted. And this is where I start to see that there is like a very nice property of Kapitan that allows us to immediately see when we make a change in the inventory, immediately see when we compile the effect that it creates, especially in the compiled subfolder, but there will be also in other places that we will discover later. There is also another benefit now, which is also very interesting, is that the moment in which we tell Kapitan how to find this specific kind of file, so as we said, we copy into a subdirectory of the classes inventory called Kubernetes. So if we go with Kubernetes.nginx, now what happens now is we've told the Kapitan that we want to merge into the target definition the content of the class that was in the that we generate into the nginx.yaml. Now what happens is if I run Kapitan compile again, and I do git status, I can see that magically all the files that had been deleted before, because this definition was not present anymore into the inventory, have now magically reappeared. And the only changes that we see, as expected, are the one that we made in the creation of this new nginx direct file and within the target itself, which gives us the opportunity to praise one of the most incredible capabilities that Kapitan offer, which is the one of allowing for refactoring of the inventory to change as we evolve our setup. But we have the guarantee that if the final inventory hasn't changed in its meaning, in its kind of rendered form, we will see basically no changes in the compiled directory, which tells us that the refactoring was 100% respecting the previous setup that we had. Okay, so going to do another thing now. And this is something that I do very often. I going to add again this configuration, commit and say that we've added a new Nginx class. And we can see that the status is again to be standing that we are not, we don't see any kind of changes within Git. Now, something that the reason why, for instance, using classes is it's a powerful capability we have within Kapitan is that, as you can see here, by looking at this, you can already understand, you can give some sort of a meaning to the content of that class. Now the meaning can be functional. We can say that's the Nginx component associated to Kubernetes, but we could also use classes to define some specific business related kind of a logic that we might want to capture within our configuration. Let's assume, for instance, that we want to now change some of the Nginx configuration, starting from this kind of setup we have here. And we're going to say that, and again, this is like a little bit of magic that for the time being, we just need to assume exists. So just have this this is dogma of knowing that this magic exists. We're going to get into the details of that later. But I'm going to create an env sub key. I'm going to say profile, and we're going to say production. Now, let's assume that this meaning, that it has some sort of a meaning of some sort. At the moment, we're just playing with the inventory. So we're going to run Kapitan compile again, and provided that I've used the correct syntax, what we are going to see when I do git diff is that we can see that within the Nginx bundle file, so within the deployment that we had before, we've now seen that there is a new env variable being added to the deployment, which has an arbitrary name of profile and a value associated to production, right? So what if we want to be able to basically set specific variables when this component is being run in production mode and when this component is being run, for instance, in development mode? So other tools, for instance, like Helm, to give an example, would have some sort of value files, and within these value files you have all the information related to that specific configuration all crammed into one file, and perhaps you can somehow use some comments to understand whether a specific set of parameters enable a production setup rather than a development setup. Let's assume that there is it's a matter of defining for the development environment some m variables and some specific memory characteristics, while for the production environment we obviously want to use something slightly different. What Kapitan allows us to do is to create classes that we can then use to capture all those kind of parameters at once, and visually gives us the ability to distinguish between a setup that is meant to be for Nginx to be running in production or in development. So let's go and create something like, as I said, it's something that is completely arbitrary for the time being. Let's go create something like profile dot production, and obviously we need to create the directory called profile and the file called production. And for the time being, I'm also going to create another file called development. Now, rather than hard coding this kind of m variable or this kind of values inside the main definition of Nginx, which we might want to decide to, because it's a shared class, we might decide to use it in multiple situations where the setting the env to be profile doesn't really match the requirement. We are going to embed this kind of information within the classes that we just created. So what we do now here, we're going to copy the full kind of, for convenience, we're going to copy the full content and duplicate it inside both the production and the development classes that we created. And because we want to just add the specific m variable, and we are okay with using the same image that is being defined for the time being, we're going to remove the image definition. So we're just going to add this specific diff that we have here, which we can now remove from the Nginx class. And we are going to redefine in both places just the fragment of Nginx of a configuration that, when it's being merged together with the original Nginx definition we have here, will give us the final desired setup for Nginx. So let's go into, let's fix it for development as well. So we said for development we imagine it to be development. Here we go. Now what we're going to do is run, in this case, rather than, well, we can run Kapitan compile again. If we don't run Kapitan compile again, we will see that once we do git diff, we are again getting exactly the same setup, the same kind of configuration that we had when we added the m variable directly into the Nginx class file. However, the benefit now is that within the file, I'm able to visually explain that this specific target has some sort of a configuration that comes from what I have defined as internally within to map some sort of business reasons. I map to be profiled or production. And obviously, if I do again git add git commit add production profile, I can decide to instead switch this to be of type development by just changing the class. So we don't have to make changes anymore to the Kubernetes class that we have here. And if I run Kapitan compile now for Loom, we should see that the m variable that before used to be production is now development. Now this is very powerful because there may be, this is a very basic example here where the production, there is only one variable being used, but it might be a much more complex setup that perhaps enabled for the development other things. So for instance, in development, we do want to change the image to be a slightly different version. Perhaps it could be Nginx, but with a devel label. And there might be other aspect that we want to say. Rather than profile development, we could say something like some sort of what can I say, feature new, it's kind of activated already. So perhaps there is a feature called routing that is being activated because it's a development kind of environment. Or actually something that might sound more development is like security equal false, because why not? right? So let's see what happens now if I do Kapitan compile and git diff. We can see that now the adding the development profile class has added an even more kind of customization that we would have in the production one. We now see that the development class has the ability to define more and more specific alteration that we might want to do to the basic Nginx setup that we had before. Obviously, because of the way we organize things, we can add, explain this even further with comments. This is obviously, it's always good to add a description to explain why we're doing things. But this kind of explains some characteristics about the inventory and which are fundamental to understand how Kapitan works. So let's go through those kind of characteristics again, or features again. So first of all, we've seen that we are able to use variable interpolation for pointing to, for setting a parameter with the content of another value that is somewhere else defined within the inventory. We've seen how to create classes, we've seen how to add classes, and we've also seen how to merge fragments that are defined into a class into a higher, to modify something that was previously defined into a higher class, like in this case Kubernetes.nginx. As a final kind of thing that we might want to do in this case, just to explain a little bit more, to repeat also all these kind of characteristics that we've defined already, all these kind of features. We tend to avoid, Nginx, sorry. We tend to avoid overriding things in this kind of, it becomes a little bit difficult to see, especially if there are some things that you want to override often. It's not nice to repeat this kind of values multiple times, right? So first of all, let's switch this from devel to development, just for the sake of this next kind of demonstration. But as you can see here, we are kind of duplicating the same value, the development and development here for the profile. So what we tend to do in this case is actually push that kind of parameter outside of the component being defined, because there might be many other places where we might want to reuse and define that this is like a development mode. And perhaps we can define here at this root something like profile development. And now here, rather than writing development like hard coding development, we can use again variable interpolation to point to that value that we defined before. So as you can see here, becomes profile, and we need to do the same here as well. Now we can do this a little bit better somehow, because in the default component, the image at the moment is being defined with just Nginx. So as you know, Nginx usually uses the Docker. When there is no kind of tag defined, it refers to label latest. So what we could do here is that we actually define something called profile, and we say that the default setup for profile will be latest, and so we can basically reuse the same approach that we had here. So now we are saying that Nginx will load the tag that is associated to the profile string that is being recognized. Because these two kind of values here are somehow a repetition, we can drop this from the configuration, and we kind of made it much more generic in a way, because now we only need to define this kind of a profile variable up here. So we're going to do the same for production, and we're going to define production here as well. And again, if you look at these two files, you can see that now even these two variables are actually the same. So we could carry on and create more and more different kind of configuration. Allows us to finally get to a point where by just changing one variable, we are able to affect through variable interpolation, we are able to affect the behavior of multiple applications at once. I'll stop here for the time being. This is, I think especially this last part might have been a little bit more difficult to grasp, but it does allow us to see a couple, even if in this specific case we don't have an actual explanation of why we would use profile in this way. I think just focus on the fact that we are able to use variable interpolation and merging different kind of classes together, and we will see how to make use of that effectively in another time where we go into dwell into different kind of aspect of Kapitan. Let me know if you've enjoyed this video, and follow us for more updates. Bye.